Okay, good evening everyone. Last class we discussed about chloralkali process. Today we are going to discuss about bleaching powder preparation and washing soda, baking soda, and their particular uses and all. This is also important part as a CBSE board exam is concerned, right? No, see, try to understand here. See, generally, we prepare the three product, right? One is a sodium hydroxide, which is called alkali. One is chlorine gas. Another is hydrogen gas from the chloralkali process. So, as you know, at the cathode we got the hydrogen gas. As near the anode we got the chlorine gas, right? And say, similarly, at the below the cathode we got the sodium hydroxide. Okay. One more thing you forgot to I forgot to explain actually. So do you know why this sodium ion, even carrying a positive charge, which is not going to liberate it where cathode, right? So just think here. Just I'm saying here. Hmm. Now see here. So as we discussed here after the in the chloralkali process, this is diagram, right? So now see here what I'm saying actually. See, now try to understand what I'm saying here. Why in this process? Why in this process sodium ions are not going to liberate here? You try to understand. Suppose sodium ions are there. If they are undergoing, they are gaining one electron and they're going to form a sodium atom. Sodium, once it's not sodium, after gaining electron it is going to become sodium atom, right? If sodium atom is going to form, immediately what happens, as there is an H2, so you know very well sodium atom is highly reactive metal, right? Immediately it will react with the water, it is going to form again back to sodium hydroxide. That's why during explanation they given here hydrogen gas is going to form. Hydrogen gas is going to liberate here NaOH. So Na plus and OH minus are combining and they are going to form a sodium hydroxide. Just remember. Okay. Now come to the next topic, which is a preparation of bleaching powder. So now we can see here. Just remember this bleaching powder that we write here. So bleaching powder preparation. Okay. Just I'm saying here the bleaching powder. So this bleaching powder is prepared by taking the one is a calcium hydroxide. They will take here calcium hydroxide. Calcium hydroxide CaOH taken twice plus this should be an dry calcium hydroxide plus this one they are passing the chlorine gas gives rise to CaOCl2 plus one more they give I think H2O. Okay, this is a reaction you can understand here. This process CaOCl2 is going to form here. So CaOCl2 is think what it is called. Chemical name is calcium. Just a minute, okay. So you try to understand this reaction. This reaction calcium CaOCl2. Okay, this name is chemical name is calcium calcium oxychloride. Calcium oxychloride is a chemical name. Remember, it is a chemical name. What is the common name, sir? Common name is what's it is called bleaching powder. So why it is called bleaching? Bleaching powder. Yes, remember here. So bleaching means in the Latin name maybe became white, becoming you can say becoming white. Okay, something else is have a different color, we need to remove that color and we should convert into white color. Okay, remember what I'm saying. Bleaching meaning represent becoming white, right? So suppose we discuss that. See, bleaching powder is used in a different industry. Let we discuss first, then we'll come to know what is the meaning and What is the important of that meaning? Okay. Okay, now what I'm saying here, bleaching. You have already come to know that chlorine gas is produced during the electrolysis of aqueous sodium chloride. What they are saying here, we discussed about this reaction, right? NaCl plus H2 aqueous NaCl plus H2O gives rise to three main products. One is sodium hydroxide, and one more is Cl2. One more will be an H2 gas. This is which is we called as a chlor-alkali chlor-alkali process, right? So in this one we are getting chlorine gas. We got the chlorine gas, and that chlorine gas is used for the manufacture of bleaching powder. Bleaching powder is produced by the reaction of chlorine on the dry slaked lime by by the in the representative CaOCl2 is differently they given. Let it be no issues here. Okay, let's try to understand. So bleaching powder. This is a reaction which represent the bleaching powder. Now come to the uses. First one you see bleaching cotton, linen, textile industry. Textile industry means you try to understand. It is used as a color remover. That is remember bleaching wood pulp. You know very well wood pulp color is somewhat we can say light yellow color, different color. That is again you should convert into white color, right? In that process, they are going to use a bleaching powder. Okay, even paper industry also. Paper industry we need to get a white paper, right? So it may be wood pulp, maybe different color. Again, if you convert into white color, in that process, they are using the bleaching powder as a decoloring agent. We can say better, I think so. Next one, they are using oxidizing agent. So we know very well what is the meaning of oxidizing agent, which gives O2, or we can say which is undergoing reduction, that is called oxidizing agent. Okay, so you know very well what is the meaning of oxidizing agent, which is helps helps in oxidation process. That is also we can call as a oxidizing agent. So what they are saying, bleaching powder is used as a oxidizing agent. Second one you see, third one is to make the drinking water free from the germs. So you know very well, especially in the cities, you can, I think, did you smell the water, right? So you know very well water smell. Okay, water smell will somewhat different because of this bleaching powder. Because of this bleaching powder, they will have a different smell, right? Especially even in when it is fairs, you can say jatras and all will be there, no? During that process, very huge amount of water is required for the drinking purpose for the use people, right? In that time they should make the safer, they should supply this safer water, right? So in that process they will use small chlorine tablets, things will be like small chlorine tablets will be there, which is able to kill the germs and bacteria present in that water. Very huge big water tank will be there. So in that time, in that water tank, they used to pour the many very huge amount of chlorine tablets, bleaching powder tablets, which will makes the that water free from the germs. That is the advantage of bleaching powder tablets and all. Okay, next one come to the baking soda. Okay, so when come to the baking soda, so try to understand here, this baking soda. See, this baking soda is prepared by the process called a Salve process. In that, different chamber will be there. Let to discuss and different reactions will take place. Okay, so let me explain this process here. So now you can see here. So these are different chambers. So now see here, this is an flow chart. We can say flow chart of solve process. So in this process, you try to understand. Here is a brine, right? So you know very well what is the meaning of brine and all. And after here is an ammonia gas will be there, and carbon dioxide gas will be there. And where they are specifying, sir, here is a filter, and here this is carbonation tower. It's a very important carbonation tower where our main reaction is going to occur. And here there is a lime kiln, something called lime kiln. You try to understand. So the lime kiln and ammonia tower recover will be there. Ammonia absorber will be there here. Ammonia, you see, brine, they are sending brine here, and again next you see from the brine filter is going to take place here. Ammonia here you can see there, with ammonia brine is entering into the carbonation tower. Again, for these three mixtures, they are sending carbon dioxide gas here. That is very, very important. Again, from here, when reaction will take place, these are the two products are going to form, right? Then after, from that, they are going to take the only one product, our product NaHCO3. NaHCO3. That is important, okay? So then after, it will write, okay? A second. Okay, now you can see here. But I understand here ammonia observer is there. This is remember, and this is ammonia recovery table, and this is limekine. This is carbonation tower, and this is you can see this is let me write better reaction here. First thing you should remember here. First thing you should remember. First, something called brine. Okay, it's from brine here. Remember, this brine is nothing but there is an sodium chloride. Okay, plus water. This is called what's a brine. Okay, this is called brine, and this brine is introduced into the what's that? The given ammonia absorber chamber they are sending. You remember here there is an addition of NH3. Ammonia is going to add here. Now total how many things are there with us? We have a aqueous NaCl plus H2O plus one more is NH3, and these three are introduced into the carbonation carbonation tower where something is going to pass us through, which is that this is carbon dioxide. You think this is called limekine. So this is called a limekine. In limekine they are taking calcium carbonate limestone, and they are eating very strongly, and this is calcium oxide is going to form. Along with that, carbon dioxide gas is going to form. This carbon dioxide is now then sending into the carbonation tower. See, in this reaction now, four things: NaCl plus H2O plus carbon dioxide. Now, what we are added from the limekine plus ammonia. These four are going to react. Four are going to react. Okay. So after the reaction, what happens, sir? After the reaction, you know very well. So here, two main products are going to form: sodium hydrogen carbonate NaHCO3 plus ammonium chloride NH4Cl is going to form. Now this is our main product, right? This is the baking soda. So what is the formula of baking soda, sir? Baking soda formula is NaHCO3. With the chemical name, chemical name is what, sir? Sodium hydrogen. Sodium hydrogen carbonate. It's an important chemical name. Okay, now see we got this sodium hydrogen carbonate. What about this thing, sir? What about this thing? See here. Now let me write here. Somewhere we got this reaction, right? So that here you see, here we got calcium oxide. From where, sir? From the limekine. This calcium oxide is going to treat with H2O. So it forms a CaOH taken twice, which is also called what, sir? We can say it is an lime water. Okay, now we got lime water, right? Remember lime water we got. This lime water again in the from the reaction whatever we are getting here. Let me use the different color to differentiate this. If here we got a ammonium what's our chloride, right? This is going to mix with the lime water. Okay, this is going to mix with the lime water. Now this lime water CaO is taken twice plus NH4Cl is going to react, and they are going to give rise to one is CaCl2, I think. One more will be NH3. One more is I think H2O. Okay, this is going to form. Now this ammonia is going to filter. It is going to use again back in this process. Okay, from the ammonia absorber. You try to understand. Here we got a calcium chloride and we got ammonia and we got a water, right? So these are the reactions. Now you see, now come to the back here. So now we can see the diagram here. I think where we used diagram, where is the diagram? I don't know. Now you can see the diagram here. Okay. Now see here. You see here what I'm saying here, ammonia. This is a brine. He's here. So in this brine we have NaCl plus H2O that is introduced here. Means here we added NH3. So let me write different color here better. Okay. Now see we got here NaCl. Okay, ammonia is added here along with this one. Three are there. These three are going to through the filter here. It is they are going to send here. These three will come here. One is NaCl, one more is water, one more is CO2 gas. Okay, sorry, not CO2 gas. We can say is ammonia. Where these three are mixing with an water CO2 gas, which are taken from the lime kiln. From the lime kiln, they are going to introduce the carbon dioxide gas and these four are reacted and they are going to form a ammonium chloride and sodium hydrogen carbonate. Sodium hydrogen carbonate, ammonium chloride and sodium hydrogen carbonate. Right, understand? Here our product is going to form here. Now see here. After these all things you try to understand from the lime kiln, then the lime kiln. From the lime kiln, you try to understand there is an calcium oxide is going to produce and it is going to react with the water and it gives rise to calcium hydroxide which is introduced into the ammonia recovery tower where these two products are there. This is going to react with ammonium chloride. It is going to form CaCl2 plus water plus ammonia. Again from here, ammonia is taken. Ammonia is taken, it is taken into the ammonia absorber. Again it is going to send, it is going to make to react with our brine. Again same process will be continuous, right? Okay, now come to the baking soda. Important of baking soda where they are going to use. Okay, the first thing is you should remember this baking soda used, where it is used. Okay, let me discuss. First one they will use for the, this baking soda used for the first one is for the fast cooking. Fast cooking. Okay, fast cooking. Second thing is it is used as a antacids. Antacids, and third one they are used as a soda ash fire. Okay, soda ash for extinguishing. Okay, soda ash for extinguisher, right? So how they will use in a fast cooking, sir? This baking soda will be, is try to understand. See how this baking soda will be helps in the fast cooking. You try to understand. Suppose this is a grind, right? So this is a grind. Upon the grind, there will be something called endothermic layer. It seems okay. So when this baking soda is heated in the what you call container, so usually it is going to produce carbon dioxide gas and water and sodium carbonate Na2CO3, which is creates the alkaline medium. What we can say basic medium. In the basic medium, endothermic layer is going to become a soft. So if once outer layer of the grains are going to become soft, definitely it is help us to make the inner substance to boil fastly or cook fastly. So in that way, in such a way, baking soda will help us to helps in the fast cooking process. Just remember, it is going to softening the endothermic layer of the grain. In that way, it is helps to cook the cook fastly. We can say, okay, right? So now come to the next use. Okay, so Now what I'm saying here, suppose you think like this is the grain, right? So this grain contains something called outer layer. This is called, you can say, endothermic layer. Endothermic layer will be there, and this layer is when this, see, I'll write a reaction here. So NaHCO3, sodium hydrogen carbonate, on heating it is producing Na2CO3 plus CO2 gas plus H2O. So this is nothing but a basic environment is created. In this basic environment, this upper layer, this what we have here, upper layer is, right, this upper layer is, this layer is going to become a soft. So if once this layer is going to become a soft, so inside grain is going to cook very fastly, boil very fastly. In that way, this baking soda will helps in the fast cooking process. Okay, this is the first use. Come to the second use. What is second use? Second use, you see what is second use here. So second use is used as a antacid. So here, so first you should try to understand what do you mean by the antacid. So it is nothing but we can remember like a anti anti-acid, not anti-acid, anti-acid. Okay, anti means opposite to the acid, so we can say it is simply, we can say it is act like a base. So it is used in the antacids means, suppose if in our body, time to time there will be production of dilute HCl for the decomposition of food, right? Suppose if you are not having morning breakfast, or you are going to skip the afternoon lunch, okay, so in that time, amount of acid, excessive amount of acid is going to produce. Okay, not produce, we can say present acid is going to become what's a excess, because morning and afternoon you didn't add a food, so it becomes whatever acid was, it is going to become excess. Now we need to neutralize this one. This is acid, right? So our baking soda is NaHCO3. This is nothing but it is an mild base. It is mild base. Okay, so in these cases, it will react. It is going to neutralize this acid. So acid is going to produce what's our H plus ion. Okay, so this H plus ion can be neutralized by the base, right? So it is going to produce NaCl plus CO2 gas plus H2O. So this reaction is salt and water is going to form. This reaction we can consider as a neutralization reaction. Neutralization reaction. So in this way, it is going to neutralize the excess acid produced in our stomach because of lack of food. Okay, this is the second use of the baking soda. Come to the third use. Okay, what is the third use of the baking soda? So you can see here, baking soda they given is here, soda acid fire extinguisher. Soda acid fire extinguisher. So how this soda ash fire extinguisher understand here? Again, come back to the this reaction here. Soda ash fire extinguisher. You try to understand it. Now, see, now this baking soda, sodium, hydrogen, NaHCO3. NaHCO3 react with a acetic acid, CH3COOH. Okay, this is acid, right? So when this baking soda is nothing but metal hydrogen carbonate, we can write as MHCO3. When MHCO3 is react with the acid, it produces mainly CO2 gas. CO2 gas, you know very well, CO2 gas have a ability of extinguish the extinguish the extinguishes the fire extinguishers. Okay, fire extinguisher we can say. So in the when this baking soda is going to react with the acid, it forms main one is salt. Suppose you think in this reaction, if it may be salt, maybe CH3 COONA, sodium acetate plus CO2 gas plus H2O. Anyway, so sodium hydrogen carbonate react with the acid, forms CO2 gas, which have ability of extinguishing the fire. That's why, so it is also used in the preparation of fire extinguisher. Preparation of fire extinguisher. So one more thing is one more important thing we forgot to explain, that the preparation of baking powder. So this baking soda is also used in the preparation of baking powder. So question will be like this: baking powder is better than the baking soda. Baking soda. Okay. Another question. Justify. They'll ask that justify the statement. So try to understand. Simple thing is here. So when the baking soda NaHCO3 is heated or during cooking process, this is going to produce Na2CO3 sodium carbonate plus CO2 gas plus H2O. So we can see we heard word like crispy pakoras. We can say tasty crispy pakoras, fluffy buns or soft buns. This all because of this gas. This gas is there. Let it be. This Hmm. Let it be. Now come to the point actually. Why baking powder is better than the baking soda? See, this is a baking soda. So this is baking soda. So I am using in the cooking process. You try to understand. Now in this process, so one more. Now in this process, what happens actually? Now in this process, Na2CO3 is going to form. This Na2CO3 is nothing but it is a base, right? It is a basic substance. If it is basic substance, it gives what kind of taste? Or it will definitely it is going to give the bitter taste. That is the disadvantage of sodium hydrogen carbonate, or we can say baking soda during the cooking process. So that's why they can't use the, or they can't use the baking soda. So instead of baking soda, now suppose you think like I am going to use a baking powder. So first let me know about what is the meaning of baking powder. So this baking powder is nothing but baking powder. Okay, baking powder is nothing but it is mixture of sodium hydrogen carbonate plus we can say it's an nothing but edible edible acid. Okay, so acid means what, sir? Remember, they are going to produce H plus ion. Okay, so now see, normally what happens, normally if I taken the NaHCO3 baking soda, again I am going to supply the heat energy in the cooking process, it is going to form a Na2CO3 sodium carbonate plus CO2 gas plus H2O, right? Okay, now along with this one, you see, so you know very well as we discussed earlier, this is basic. This is basic. Then it is going to produce what kind of taste? Sir? It is going to produce the bitter taste. Okay. Now this is going to neutralize with this acid. Now this two will be, so this just I'm writing here. Now this Na2CO3 plus we have one more thing. What, sir? We have a mild acid. So this mild acid. So we have said that this is a base, right? This is base, and we have a acid. Base plus acid. What happens, sir? Again, neutralization reaction. Neutralization reaction is going to take place. A result will be what, sir? Result will be salt plus water. So now there is no bitter taste because we used because we used mild acid, right? So now try to under. So when we are using only baking soda on eating, it is going to give the sodium carbonate Na2CO3 plus CO2 plus water, right? So but when we are adding the edible mild edible acid, that acid is going to react with this Na2CO3, which is a bitter taste. So now between the Na2CO3 and this edible acid, reaction is going to occur, which is called as a neutralization reactions. By this process, bitter taste is nullified, or we can say basic character of Na2CO3 is going to nullified. That's why the reaction between that acid and this Na2CO3 is also called a neutralization reaction. You try to understand. Okay. So now come to the next concept. Okay. What is the next concept they given here? So you can see here they given about this washing soda. So now how this washing soda is prepared, sir? This washing soda, they given, let me read out this another chemical that can be obtained from the sodium chloride is sodium carbonate NH2 washing soda. You have seen about the sodium carbonate can be obtained by heating the baking soda. Recrystallization of sodium carbonate gives the washing soda. It is also basic salt. So now simple thing is what they are saying, sir. See, after reaction between this After heating, Na2CO3 gives rise to, sorry, NaHCO3 gives rise to Na2CO3 on heating, plus it gives H2O plus CO2 gas. Okay, so now this is basic salt, right? This is a basic substance. This one they will take Na2CO3, sodium carbonate, and they are going to add 10 molecule of H2O. This gives rise to Na2CO3 dot 10H2O. This name, chemical name is what, sir? Chemical. You see, this Na2CO3 is also called soda ash. Soda ash. Right? Understand? Soda ash. Now see here, remaining is Na2CO3 is added to the H2O. It gives rise to sodium carbonate decahydrate. Chemical name is what, sir? This is sodium carbonate decahydrate. Okay. So let me write here. Okay. Now